Newton's first law is quite hard to see here on Earth, but in space, far away from any forces, it becomes much clearer. Quite simply, all objects stay as they are. All objects either stay at rest, they don't move. But when they start to move, they will continue to move with a constant velocity in a straight line forever and ever until they hit something else or another force comes along and changes the velocity and direction of the object. Here's an example of Newton's first law. The blue ball is not moving. The graph below shows its velocity is 0, and the ball will stay at rest, that is with 0 metres per second, as time passes. We're now coming up to the 35-second mark and the ball has not moved, its velocity is 0. And that's what Newton's first law really states. It states that an object will stay at rest unless an unbalanced force acts upon it. Now when an unbalanced force acts upon it, its velocity is going to change. We can see the velocity now changing. Once they release the force, you can see that the ball will move with that velocity and its velocity will be constant over time. And that's really the second part of Newton's first law statement. A ball or an object will move with a constant velocity unless an unbalanced force acts upon it. And here's unbalanced force acting on it here, and you can see that its velocity is changing. Take away the force, and you can see that the velocity of the ball remains constant. That's that green part of the graph there. If I apply a force in the opposite direction, I'll change the object's or the ball's velocity, change its direction. Once I remove the force, you can see that the ball's velocity will remain constant. So two things happen in Newton's first law. When an object is at rest, it will stay at rest. When an object is moving, it will continue moving with that velocity, with the constant velocity. Unless an unbalanced force acts upon it, then the ball's velocity will change and therefore it will accelerate. And that's where we lead on to Newton's second law.